Okay, so yeah, guess I'll be going through this notebook, which basically has some prerequisite exercises, prerequisites for skilling up as an ML engineer to focus on AI safety. So it starts off with a bunch of points on overview. It has a bunch of resources to learn math, algebra, statistics, programming, and so on. So I'm going to skip uh, all of this, not because I know it very well, but I think the return on um, investment's very low at this point. So I'm going to jump to exercises. So yeah, so I guess so I guess this is basically it. The section on Einops, Einsam, and tensor manipulation. So yeah, so we want to learn the basics of Einstein summation and how to use this particular library to do this summation to work with your tensors. Yeah, I'm not sure why there's Einops and there's Einsam. I don't know what one does and what the other does. I don't know what the differences are. But I guess this is a good place to start. Oops. Okay. So we have Einops, powerful library for tensor operations in deep learning. Okay, I think this makes sense. We'll look at this tutorial and then just go through this really quickly. Okay. We implicitly sum over repeated indices. Okay. Okay. Let's do the exercises now. Just running away. Maybe I should make a copy of this. Hmm. Well, think. Okay. Let's run now. Okay. So we have a 4D number array. First axis correspond to the number. Next three are channels, height and width. We have this utility function. Should be image or a monochrome image. Okay. So you plot the first image. Just the first channel, the first image. Then you plot everything. Hmm. Okay. So series of images follow. Create using Einops functions. Work through these and try to produce each one yourself. So include solutions. Okay. So yeah, we need to get this vertical stack. Okay, I guess that would be. Oops, how do I turn this off? Rearrange array. We want it to be a 3D. The height would be p times h. The width would remain as is. Yep, it works. And the solution is the same. We want to display the same 0 twice. Okay. Um, Repeat. Yeah, Einops repeat. Einops array of 0 chw c 2 times. That should work. Yeah, yeah, makes sense. Then we have 1 0 0 1 1. Okay, so first, okay, I want to repeat something, and the way I would repeat it is I will fill this letter, but I expect it to be C some height u C height remains same, duplicate along the width of the image, and this should simply be range uh, have PCHW want it along the height, so C uh, yeah, this makes sense to me. Oops. Mm, hmm. Guess I should just write B here. Hmm. Oh, okay. Guess I could just leave this as is. I don't care what the height is. Hmm. Interesting. Oh, I need to do slicing properly. Yeah, and it's a much simpler solution. Oh, okay, I can rearrange with this itself. Hmm, good to know. So now we want to do some stretching of the image. Okay, it's the same pixels, probably duplicated along the height. Like if I have 10 rows, we'll end up having 20 rows, and each row is duplicated immediately. I think that's what's happening. So therefore p Einops dot repeat. Take the first image. This is the size. The image should become C. It should be H2 because we want each row to repeat immediately. Uh, yeah, yeah, yeah. Okay, now we want to split the channels. Each image has 3 channels. Let me run this. Yeah. 5. Oops, start. Rearrange. Take the first image. Head. Sorry. Um, CHW. Want it to become H. 3W or CW. Yeah, this should work. Yes. So if you look at the solution, yeah, stack into rows and columns, rearrange operations, dimensions for row and column stacking. Thanks for the hint. So to rearrange, need the whole array. This is the size. It's going to change into having 3 channels. Height would become 2 times, and okay, I think there is a P1, P2. This is P1, 2, and I can pass these as parameters. So B1 would be 2, and yeah, I don't need to mention B2. Yep, yeah, makes sense. Ah, just flip the model. Horizontal and vertical dimensions. Transposing is a fairly common tensor operation. Okay, so I guess we'd still need rearrange. Should be enough. So we have the one as a size CHW, and I guess it just becomes this. Yep. Oops. Oh, Ah, okay. Not sure what. Sure what this is doing. It's right choosing. Taking minimum over what? Hmm. Let's see. Suppose we have 1, 2, 3, 4. Nope. Start reduce X W WH. Okay, did produce a transpose. Call this y1. What is this doing then? Y1. Hmm. Okay, so they're the same. Or do we have an extra dimension of this? Let's just duplicate this. So we have still the same. Hmm. Okay. Hmm. Guess both are equivalent. They must be. Let's just do something. Spend. Oh, let's just ask ChatGPT. Oh, okay. Hmm. Makes sense. All right. So let's move on to now shrink the image by half, I guess. I need to be back. Right, back. Sorry about that. So, yeah, we were about to shrink the image. We can use rearrange. I guess. No, just we need reduce. So we have the whole array. This is its size. We need um, we need a three-dimensional array, I guess. We need to first uh, factor this into a 2 by 3 uh, grid. So we need that. So it would be P1H, P2W, but this would not half the image. What we need to do is we need to reduce. Um, yeah, let's do this. H1, 2, W1, 2. Or this is college. Hmm. P1 is 2. P1 is 2, right? Yeah. Yeah, I guess this looks right. Let's see. Yeah, makes sense. Okay. Let's, what's next now? Designs, Einops operations and broadcasting. Okay, there's a lot of exercises implementing different functions. But before that, we have, yeah, so broadcasting, the same rules, tensors involved in element-wise operation. Both have the same shape. Okay, rules are as follows. Can prepend dummy dimensions to the start of a tensor till both have the same number of dimensions. Okay, suppose we have 2D batch, comma k, being a vector of length k, right? Suppose we want to add a vector of length k to the each data point. So it's prepended with a dummy dimension. No, both are 2D, same number of dimensions, and it's repeated along the first dimension. So it has shape n, comma k. Okay, you want to add x and y, find 5. This is 1, you can repeat this, becomes 3, 4, 5. This is 1, you can repeat this, becomes 3, 4, 5, and yeah, you can add it, it's valid. It's valid. Right. And the second one, I don't think this is valid. You cannot prepend a 1. You can prepend a 1 to make them have same dimensions, same number of dimensions, but once you do that, you have 2 and 6, so there's no way you can broadcast that. Yeah. And then we have, yeah, so we have 8 to 6 and 2 6. We prepare one here, we have 1 to 6. Yeah, this is valid. Okay, 21. You have prepared one. This seems valid to me. Yeah. Finally, prepared one. It's broadcasted. Yeah, this is also valid. Right. This is probably something you need to be aware about. There's no error here, but it might not be adding them the way you wanted. So, yeah, so it's a potential source of silent failures. As well to shipping times is, yeah, sorry. Yeah, if you have a tensor and squeeze at dimension 3, get 3151. Yeah, squeeze at 1, 3,5. Hmm. 0, nothing happens. Okay. So Einops operations and broadcasting spend up to 45 minutes. You'll use in practice. All right. So we have a series of functions should implement using Einops and have solutions to. Okay. Yeah. This. So we'll start with simple rearrange. Huh. So touch. Is it inclusive of and no, it's not. So should be 9 and written Einops rearrange X shape is I don't know N1 and 2 should become N1 and 2. N1 is 3. Yeah, makes sense. This passed. Let's see how they've done it. Makes sense. Same pattern as the previous one. Yes, can just do this, I guess. One have 7 and one. Yeah, shouldn't be any different. Alright, so we have something else now. Find the average temperature for each day, temperature for each week. Okay, single line using Einops reduce. Alright, so Einops dot reduce. Uh, it's a 1D array, so I have maybe n. Hmm. So we need to group them into 7 days. And the way we can do that is 2 and 7 and will be the number of weeks. And this is what we want. And we reduce by taking average or mean, I guess. Yeah, yeah. Now we want to subtract the average temperature from each week from the daily temperature. Hmm. So this is yeah, size 2, one dimensional, and temps is one dimensional of size 14. Nope, start repeat average temps size 2, right? So number of weeks. I want 7 days. And I simply return temps minus this. 1 second. Yeah, makes sense. Let's see how they've done it. Repeat the averages back to shape. This is what we've done. Or reshape temps have 7 comma 2. Should make it broadcastable with 2. Hmm. Then flatten it back to 14 after subtracting that, I guess. Okay. Temperature normalized. Subtract the average. Divide by the standard deviation. Huh. Okay, so temperatures differences already does this subtraction of average. So let's call it temp diffs. Now this is of size 14 divided by standard deviation. Deviation would be Einops dot reduce temps size, I don't know, divide by the weekly standard deviation, right? Okay, so have n weeks. This would then be size 2. Can just return temp diffs divide by std. Repeat as, I don't think I can do that. I know, start repeat std as number of weeks. Uh, Basically wanted to be like this. What's the issue here? Oops, this should work. Yeah. Or how have they done it? Find the average, find the standard deviation. Yeah, makes sense. Oh, okay, so normalizing a matrix. Each row has L2 norm equal to 1. So not the same thing. Okay. Dodge function directly rather than Einops for this task. Hmm. Okay. Each row matrix norm. Can I do? I think Frobenius norm is what we're looking for. Yeah. Let's look at matrix norm. No, what we need is an L2 norm. Vector norm. Yeah. And what we need to do is this actually. Yeah. I do not support it. Huh. I can just give an order. So I can just give two. Ah, okay. They're not close. Okay. Hmm. Sum of its elements. What? Ah, okay. 1, 2, 3. You're saying this is 1 divided by 6. 2 divided by 6 is 1/3. This is not 1/3. This is definitely not. Not sure I understand. This is clearly wrong. It's divided by sum of its elements. Hmm. Let's go back. 12 to now. Wait, what? Hmm. So this has shape 1 by 3. Right. This has shape 1 by 3. Hmm. Makes sense. So this should actually be 1. Okay. This should work now. Yeah. Yeah, makes sense. If taking norm over each row should be this. Alright, let's look at the solution. Yeah, makes sense. Now I should compute a matrix whose shape and where out cosine similarity between nth and jth rows of matrix. So for each pair, we need to find out cosine similarity. Hmm. So if you have like m rows, then you need m square cosine similarity values. Right. Let's see if we can do with reduce matrix size mn. Hmm. I think we should repeat first. Become uh, generate all possible pairs of rows. Hmm. Matrix have cosine. I need to repeat each row m times. So I actually want m, m, n. I want matrix itself repeat as m n 2 um, m1, and here I should say m1, m1 is m, and m is matrix dot shape of 0. Hmm. And now I need to, if you notice, they both have the same shape. So all I need to do, and they're lined up such that uh, matrix has uh, the m rows, and then if you look at the same m rows in matrix 2, it's the same row 1 repeated m times. And similarly, in the next block, we have row 2 repeated m times, and we have this set of m rows repeated again as a block. So pairwise, if you look at the m square total rows, you have all possible combinations uh, of rows. So now all you need to do is um, find cosine similarity. Huh. I should probably be able to do this with, okay, first you need to sum them up element wise of the normalized factors. Huh. So I need to normalize, I need to normalize them, then take element wise products. So matrix becomes matrix divided by matrix dot norm, pretty much what we have done above. I don't need to mention p, it's 2 by default. uh, Dimension is 1, keep them, yes please. And matrix 2, similarly I have, actually if I do this I don't have to do this. Yeah. um, Now I need to add these two to an element wise product. And then Einops reduce m becomes uh, choose instruction is sum. Can leave this as m squared lp m squared. Oops, got size 9. We need is a 3 by 3. Huh. Guess can do this work. Duplicate dimension m1. Hooray! It works. Oh, it's a solution. Normalize. Huh. Take the transpose and do a matrix multiplication. That's pretty cool. The columns of the matrix. This is pretty good. Yeah, I should have noticed this. Matrix multiplication, transpose, you have rows and rows. I guess it's okay. Yeah, it's definitely not efficient in terms of this the shapes you have, the matrices in between. Yeah, it's a good thing to keep in mind. Anyway, let's move on to the next one. How many more do we have? Indexing, it's a lot more for today, so we will be doing one more. Sample distribution. Let's do sample distribution. Um, Written in random samples from probabilities. Random samples. This would be n, and obvious. Now all I need to do is for each float we have generated randomly, uh, we need to check where it lies, uh, and get that index as the sample for that particular point. Uh, I mean is if we have, yeah, if you have something like this, this would be 85. Let's say n is n is 2, and let's say we have 3.2. If we take cumulative sums, 0.5.151, and you can see 0.83 lies in this range. So we sample this, and 0.2 also lies here, so we sample this again. If it was 0.1, then we would sample the second item. If it's say 0.01 or something, sample this, and yeah. So you need to do uh, basically into less than, this is of shape n, shape k. We can make this n by k. We can do that by repeating. to do uh, call it sample mask. Probably not the greatest name. It's okay. And shape in comma k. And what we need to do is sample mask some, and so you'll have like for each row you'll have like a bunch of uh, false, 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 and then suddenly it becomes true. And when it becomes true, we need to pick that index up. Uh, I guess if we treat this as as floats, and you do arc max and dim1, and yeah, that should be it. Hmm. Invalid combination, expected one of Earth's dimension. Save. We passed. Let's go. Okay, let's look at the hints. Yeah, yeah. So I'm going to save changes for now. Uh, Save a copy in Drive. It has my changes. Oh, yeah. And then till sampling time. Can close this. Let's call this YT. Ah, no, doesn't make sense. Alright, so let's just save it and conclude the stream for now.